power of the human heart. The human heart is a powerful and extremely reliable pump. Each day it takes in and discharges about 7,500 liters of blood. Assume that the work done by the heart is equal to the work required to lift this amount of blood on a height equal to that of the average American woman, 1.63 meters. The density, mass per unit volume, of blood is 1.05 times 10 to 3 kilograms per meter cube. Part A, how much work does the heart do in a day? Part B, what is the heart's power output in watts? Okay, so first of all, the amount of blood that is discharged every day is 7,500 liters. This has to be converted to meter cube, and 1 meter cube is equal to 1,000 liters. So if we have 7,500 liters of blood, that means we have 7.5 meter cube of blood. And the density, which is the mass divided by the volume, is the mass of the blood divided by 7.5 meter cube is equal to 1.05 times 10 to 3 kilograms per meter cube. So we can calculate the mass of the blood that is going through the pump every day, the heart. 7.5 meter cube multiplied with 1.05 10 to 3 kilograms per meter cube. This makes 7.875 times 10 to 3 kilograms of blood. And the height, delta H, is the average height of an American woman, 1.63 meters. So we find that the change in potential energy in lifting this amount of blood will be equal to mg delta H, which is 7.875 times 10 to 3 times 9.8 meters per second square times 1.63 meters, which is 125,795 times dot 25 joules, which is, because we have minimum number of significant figures is 3 here, reduced to 3 significant figures, this makes 126 kilojoules. Alright, so what is the power output of the heart? Well, power is the work done per unit time. So work divided by delta T. And because the estimated work done by the heart is 125,795.25 divided by 1 day, which is 24 hours. 1 hour is 60 minutes, 1 minute is 60 seconds. So this is going to give us 1.46 watts when reduced to 3 significant figures. All right. So we are basically talking about the heart here. The heart every day takes in and discharges about 7,500 liters of blood, which is 7.5 meter cube of blood. And we're given the density of the blood, mass per unit volume, is 1.05 10 to 3 kilograms per meter cube. Multiplying it by the volume, we obtain the mass of the blood that is going through the pump every day. And we are assuming that the work done by the heart is equal to the work required to lift this amount of blood at a height equal to that of an average American woman, 1.63 meters. That is an increase in the potential energy of mg delta H, that is 126 kilojoules. This is the work done by the heart to gain this potential energy. And what is the heart's power output? Power output is the work done divided by the time it takes to do that work. So we do 126 kilojoules of work in one day. So this gives us 1.46 watts of power output.